In the previous video, we created our own simple ERC20 token. In this video, we'll deploy it to the Polygon chain, the Matic chain, and we'll create an interface for people to check out their balance or transfer it to somebody else. By the end, you'll see how do we interact with a token, and I'll discuss a few ways in which you can make your token useful. But before we get into that, please make sure that you subscribe, hit the like button, and if you have any question or feedback, just put it in the comment box, please. It really keeps me motivated and helps with the YouTube algorithm and stuff. All right, then let's get started. So I've copied the code from my previous video to create a simple token and pasted it over here. So the one thing that I was not doing in the previous video was emitting the transfer event in the constructor when we were giving the total supply to the creator of the contract. So we're going to do emit transfer from address 0 to message.sender with the value total supply, and now we have a completely ERC20 compliant token. All right, so I'm going to compile it, and now that I've compiled it, I'm fairly certain that it will work, so I'm not going to test it, but I want the two things over here, ABI and the bytecode, and I'm going to deploy this on the Polygon chain. For those of you who don't know how to deploy a contract, I've made a video already. You can probably check it out. But what you essentially do is send a transaction with the data to the 0 address on your blockchain, so on Ethereum or Polygon, whatever, and with that data the chain sort of creates the contract. And the data, how does that chain understand, is basically through the bytecode. Whenever we write this code, we convert it into bytecode, very similar to how Java works, and then we deploy this bytecode sort of on the chain, and that is how the chain knows how to execute that code. So now I already have this code from the previous videos where we connect to the MetaMask and then we deploy the code. So now I'm going to start a simple server, and once the server starts, I'll open the UI. So I've started the server and I'll open localhost port 8000, and voila, everything is well connected because I've already given permission my MetaMask, so it's already showing me the wallet address. Now the next thing that I want to do is deploy this smart contract that I've created. So that I'll need two things for it. One is the bytecode that I'll copy and I'll paste it over here. Now what I'm looking for is the object key, which is right here. You can also search for object like this, and I'll just copy this object key and I'll delete everything, and I'll be like var bytecode is equal to 0x and then the whole code. Okay, and the other thing that I'm looking for is the ABI. Now be var ABI is equal to this. Okay, so now I have both the things, ABI and the bytecode, that I need to deploy this function. So I'm gonna go over here, clear everything, and just enter the two things. So I have bytecode, I have ABI. Awesome. Now I just need to call the deploy function with the ABI and the bytecode. If you want to check out the function basically is over here. It calls a deploying contract, creates a deploying contract with web3 contract, and then we sort of deploy that with the data bytecode, and there are no arguments because there are no arguments for this token. Otherwise we could have added any sort of argument over here. The ABI is just required here, but I think I could have done this without any ABI as well. Anyway, click the deploy. Here it says this is the suggested gas fees that is required, that I need to pay in Matic to the Polygon chain. So I'm fine with that. I'll click confirm, and now I just need to wait for my transaction to go through. Once that is done, I hope I'll see my address written over here. So I'm gonna just wait for the transaction to complete. It says pending over here. I don't know how long it will take. Okay, As soon as I said that, it just completed. Wow. And we have the address of contract as well. So I can just copy this and go to polygonscan.com and search for it over here, and it should be, wow, it is a contract. We haven't submitted our code yet, so it doesn't know what is the actual code of the contract. I can verify and publish that as well, which I'll do probably later. But you can see that this was created by us. This is the contract that we have created. Amazing. So I'm just gonna copy the contract address, and I'm just gonna say const address is equal to this. So we have a reference to work with later on. Another thing that I want to copy is the ABI, and I'll be like const ABI is equal to this ABI. Now, of course, this takes a lot of space over here. So what I'm going to do is I'm just to put it at the bottom so that it doesn't interfere with our code. Awesome. So I have the address, I have the ABI. Now we have both the things that we needed to sort of interact with the contract. So let's go ahead and refresh the page. Okay, amazing. So now the next thing that we need to do is sort of interact with this token that we have submitted. Now we already have the ABI, and I already know the code. So now, for example, I want to figure out what is the balance of the person who has authenticated with MetaMask. So what we need to do is we're going to create a variable called contract, which will be null at this moment. But once we have connected to MetaMask, what we're going to do is we're going to be contract is equal to new web3 eth contract, and then ABI, which should be capital ABI, and then address, which will be capital address. Awesome. So once we have this, I believe we will have a proper connection. So if I refresh the page, there is some problem over here. And the problem is that I wrote ETH, Ethereum instead of ETH. And I believe that should not be a problem anymore now. Yep, it's not. So I should have a contract object over here where there are methods, and then there's a prominent method called balance of, and I can just be like balance of account, and I need to call this method, and it says it gives us a promise, so I can just await this over here, and it awaits and it gives me this balance. If I call the decimals method, it should return 18. Amazing. So our token is sort of working now. So now what we are going to do is we are going to write over here the balance of connected wallet is, and it's going to be a span, which I'll just close like that, and the ID will be wallet balance. So now what I'm going to do is I'm going to call initialize contract UI over here, and I'm going to create this function as well. So to that, we are going to be like const initialize UI will be a function which can be called like this. Now what we're going to do over here is we have the contract. All right, so first of all, what we'll do is we'll figure out the number of decimals that are required. So I'm going to await contract methods decimals dot call, and then what we're going to do is we are going to figure out the balance of the connected user methods dot balance of, and in here we need to provide an argument which will be the account argument. We're storing the address over here. So we're going to call account and then just call this method. So this will return us the balance. Now one thing that you'll see is that both these provide us with a string instead of a number. So how do we convert this big string into a number and use mathematics around it? So to convert these to number, we'll just wrap them around numbers so that they are no longer strings. Now to figure out how much balance the person actually has, what we're going to do is we're going to divide the balance by 10 to the power decimals, and this will be the balance to show. And then what we're going to do is we're going to copy the document get element by id code. We'll change the address to the balance over here, and then we are going to write balance to show. Great. So we're already calling this contract over here, so I can just go and refresh over here, and this is there's no wallet address connected. Await is only valid in async functions. So there's an error from my end over here, and I can just make this async function and then refresh. And great, everything seems to be working now. The only thing is that it shows 99.99,999 instead of 100,000. This is because of the difference in the way JavaScript sort of works with numbers. So to work with big numbers, we will use this library called ethers.js, and to install that, I'll basically add links to that in the description. But to install that, it's a very simple command. Just copy this and paste it over here. Hopefully this should sort of show up. There's no error, so it's sort of installed perfectly. And then there's a module called big number in this ethers.js, so which sort of explains how do we work with big numbers. I can sort of call ethers dot big number dot let's say from, and then we'll add like a huge number over here, and that is how we get this big number. We will go over here, and instead of using number, we'll just use ethers dot big number dot from. We're gonna do this at both the places. So what we're going to do is we're going to leave the decimals part just as a number, but for the balance we're going to do ethers dot big number dot from, and then we are going to be balance dot divide, and we divide by 10 to the power decimals. So let me just convert this 10 to the power decimals into a big number as well. We're going to do var divisor is equal to ethers dot big number dot from 10 to the power decimals, and then I'm going to divide with divisor. And then one more thing that I need to do is add a string over here so that it's easier for big number to read this. Now if I go back and refresh, it works. It gives me my balance, which is 100,000. Awesome. So now it's telling me what my balance is. So basically that is the amount that I can transfer as well, correct? Now that I can see my own balance, the next thing that I want to do is to be able to send these tokens to somebody else. Now to do that, we basically need a form which when submitted sort of opens up a transaction and transfers the token from you to the address that you're trying to send it to. So let me create a form over here. So hopefully these two should show up now. Yes, I'm seeing the address and the amount that I want to send. I'll just add one more BR. Not the best strategy to add BR, but whatever works. And then I need a submit button. Send. I'll also add IDs to these. ID form address and another ID, form, amount. Amazing. So we have the send button as well. I think it also needs a couple of BRs, and we are done. So once the form is ready, once we have initialized the contract UI, what we can do is we can get the document by ID, and the ID is transfer form, and we can add a simple on submit over here, and we'll just do alert submitted form as of now. So I'm going to refresh and I'm going to press send, and it said submitted form. Great, so it alerted me. Instead of that, now let's add a function over here. Now what should go into this function? What we'll do is we'll go and see what is the contract method that helps us transfer, and the name is transfer. All right, so it requires two parameters, and I think the parameters are two, like basically who we are sending it to and the amount of value that we are sending. Awesome. So to do that, we're going to make this async. We are going to use our contract methods, and then the name of this method is transfer. The first thing that we need to enter over here is the address. Okay, and the address we can find through this. Actually, what I'm going to do is I'm going to capture this in a variable. The value will be dot value, and var amount will be document dot get element by ID dot value. Now we need to convert this amount to a big number. Dot big number dot from the amount. All right, amount now is this big number. Now I need to multiply this with the number of decimals that we have, because on the blockchain we can't send floating amounts, we can only send integers across. So what happens is if the decimals are shown 18, the UI sort of converts the total integer that you're receiving. So 1 into 10 to the power 18, it divides that by 10 to the power 18, and then it sort of shows you how much amount you have. So if I am sending one token, I'm actually sending 1 into 10 to the power 18 amount of token, if you know the UI is not involved. If you just talk to me only in terms of the amount sent if the blockchain is concerned. So now I sort of need to multiply it with this divisor. So what I'm going to do is I'm going to pull this divisor up over here, and as soon as I get the value divisor, I also add multiplier as divisor. Great, so the actual amount to be transferred was amount to transfer is equal to amount dot multiply with multiplier. Great, so let's say if I do 12 over here, I need to refresh this first, and let's say I do 12 over here. So if I want to figure out the value over here, the amount is 12 in string. If I convert it to big number, it converts like this, and the amount that I need to transfer will be this amount to transfer. And if I convert this into string, the value that I get is 12 followed by 18 zeros. Amazing. So now I have both the things. I will just add to address and then the amount to transfer. Now because it's a writable function, and by that I mean it changes the state of the contract, so what we need to do over here is, instead of calling the simple call as we were doing, we need to call the send function. Here we need to add the from, which will be the account. This is the bare minimum you need to add. You can also suggest the amount of gas that is required and all those things, which is not required as of now, but I mean that is something there just to keep in mind. You can figure out what all things that we will require, by going through the Web3's documentation. and I also need to add a wait over here. A couple of things that I can also do is add event, and then in terms of event dot prevent default, so that as a form it doesn't really submit. The final thing that you need to do is add a toString over here, and then we can go over here. I've specified an address of my friend, somebody who had bought one of my NFTs, and I'm going to send one token to them, and I click on confirm over here. Now we're just waiting for the transaction to complete. And lo and behold, the transaction has sort of completed. Now hopefully if I refresh, this should reduce by 1, and it has. So that is how you deploy a token, check your own balance, and send some amount to somebody else. Another thing that we can do over here is check somebody else's balance. So let's say I have this address, the one that I sent one token to. So I'll just call it A, and then what I'll do is I'll go to contract dot methods dot balance of, and then I'll put A over here, and then just call it, and then await this thing. So it should return 1 followed by 18 zeros, and it has. So this is how you sort of interact with a deployed token. Now there are a couple of things that you can do. Let's say you're creating a content website, all right? So what you can do is you can restrict access to a certain part of a website or certain content, and just be like, only the people who have my token, and if they have it more than, let's say, X amount or Y amount, only then they will have access to this content or something like that. So that will be very easy to build. What basically you need to do is create a function called has access, and then it needs to be asynced. You can just be like it accepts an address, and you can be like contract dot methods dot balance of. All right, so we have converted our balance into a big number, and we're saving it in the balance variable. So if balance dot lte, or actually greater than equal to, and let's say we do ethers dot big number dot from 1 and then 18 zeros. So you can see over here it says 18 characters, so we have 18 zeros. So if balance is greater than or equal to 1, in that case we return true actually, else we return false. And only if the user has access, and let's say I'm talking about the current account only, the one which has authenticated. If the user has access to content, we can just be like, if the user has access to content, we'll just be like alert for now, the secret is blah. Otherwise we can just be like alert, you can't find the secret, and there's a small mistake in my part over here, and then I save it, and then I go back and I refresh, and it checked with the chain, and it figured out that my balance is greater than what was required. So it says the secret is blah. But let's say I increase this from 1 to 10, 100, 1000, 10,000, 100,000. So the balance needs to be greater than or equal to 100,000. And now I refresh. So in this case, as soon as we figure out the balance is less, it says you can't find the secret. And that is how you sort of restrict access to people who have your own token. So this 100,000 ideally could have been, let's say, 1, this means 1. If I remove 1 0, it's 0.1 token. If I remove another 0, 0.001 token. So people will need to have 0.001 token to get access to whatever. Alright, so this is how we sort of work over here with the token and the balances, and how do we add utility to those tokens. So this sort of concludes our series on tokens. The next that I think I will pick up is going to be around NFTs. I'll explain what does it mean to have an NFT, how does the technicals of NFT work, how does the NFT know which of the art it's supposed to be connected to, or whatever it is supposed to be connected to, and it's going to be a lot of fun. So hopefully I will see you next week as well. Make sure you subscribe to my channel and send a like to this video please, or just a comment, so that it keeps me motivated to get the videos out as soon as possible. On that note, thank you so much for watching my video. I hope to see you again soon. Bye bye.